Okay, number 42 has a few parts to it. It says convert the following units. So we are going from the metric system to the US customary system of measurement, centimeters to inches. So we have a little process here. We can use some fractions. We're going to take the 254 centimeters, put it over 1. That does not change the value. We're going to multiply by another fraction, the desired unit that we want to convert into, we want to take centimeters into inches. So we will put the inches in the numerator. Okay, sorry, I had a phone call there. I think I left off by saying we have centimeters in the numerator, and our desired unit of measurement that we want to get into are the inches, and we're going to leave that in the numerator. Since we want to get rid of the centimeters, we will find out what 1 inch represents in terms of centimeters, because we want to cancel those out. And we know that 1 inch is 2 54 hundredths of a centimeter. And basically what we did there was we were able to eliminate centimeters in the numerator and denominator, and work out the rest of our conversion by multiplying straight across like we would always do. You can look to cross cancel or multiply straight across and reduce. So now that our centimeters are deleted, we have 254 multiplied by 1 is 254 inches over 1 times 2 54 hundredths. All right, now let's reduce that. So you would take your numerator and divide it by your denominator. Since you don't have a calculator, you can do it old school here. Divide by 2.54. Recall you can't really divide by a decimal, so that 2.54, I'll just write it out here. You're going to move that decimal 2 times to the right to make it a whole number, and we're also going to have to do that on the inside, so we'll move it 2 times to the right. We'll add some zeros and bring that decimal straight up, and go ahead and do your division. And I believe this is going to be 254 subtract 0, bring down your zeros, and 254 goes into 0 times. So you're going to end up with 100. So final answer, 100 inches are in, 254 centimeters is equal to 100 inches. All right, so the next few will hopefully clear that up. That may have been a little confusing. It was the first time of seeing that. So now we have 5 yards squared is equal to how many feet squared? All right, so same idea. Let's go with how would you represent 5 yards squared in a different form? We'll go 5 times yard times yard. There's your 5 yards to the second power. And putting it over 1 does not change it. We know that we want feet squared. So we're going to have 2 of them. So we have feet and feet. There's your feet to the second power. We're trying to get rid of the yards in the numerator. So we need to figure out, I want to get rid of 2 of them. So what would our conversion be for feet? Well, what's our comparison of feet to yards? We know that there are 3 feet in 1 yard. And let's cancel. So we have a yard in the numerator, 1 in the denominator, they cancel. Another one in the numerator, let's cancel it in the denominator, and multiply straight across. So we have 5 multiplied by 3 is 15, multiplied by 3 is 45. Our desired unit was feet squared, all over 1. Final answer. A person is 1 8/10 meters tall. How tall is the person in centimeters? So we are looking at the metric system for both of these units. So we can think back to science class. We've done it in math. We have the little chart. All right, King Henry, or however you learned it, we know that this is our base unit, our base 10 area, and we have 1 8/10. So if we have 1 8/10 meters, we need to go from meters, which is a base unit, all the way over to centimeters to the right. So let's count the tens places that we're moving. We moved 2 of the tens places, so we're going to take our decimal and move it also to the right 2 of those places, and we're going to have to add a 0. So we have 180.0, and what are we looking at? Centimeters. Final answer. 2 cubic yards equal blank cubic feet. Cubic means we are in the third dimension, so we have a unit to the third power. So we have 2 cubic yards. Let me just quickly write that out how you would see it. 2 yards cubed is equal to blank cubic feet. So feet to the third power. All right, now let's do our conversion. We know that we have 2 times yard, yard, yard all over 1. Doesn't change the value. Multiplied by, we want feet cubed, so we go feet, feet, feet. There's your 3 of them. And then what's the relationship between the feet and the yards? Because I want to eliminate the yards. We know again that there are 3 feet in 1 yard. All right, and let's do our cancellations. All right, so 1 in the top, 1 in the bottom. 1 in the top, 1 in the bottom. 1 in the top, 1 in the bottom. And multiply straight across. 2 multiplied by 3, multiplied by 3, multiplied by 3. What do we have? 9 times 3 is 27 times 2 is 54. The desired unit, we wanted feet cubed all over 1 times 1 times 1. All right, final answer. 1 hour equals blank seconds. We are in the same unit of measurement, time. So hours and seconds, I don't think you really need to set up any fraction work here. So let's just talk about what an hour is. 1 hour is equal to 60 minutes. And we know that there are 60 seconds in 1 minute. So 1 minute is equal to 60 seconds. And if you think about 60 minutes at 60 seconds, that is quick multiplication. So 60 multiplied by 60, you got 6 times 6 is 36 with 2 zeros. All right, final answer, we have 3,600 seconds in 1 hour. Final answer. All right, this one's a little bit more difficult because we have a few different units that we're going to have to convert. So they want to know how many feet do you have per second in 10 yards per minute. All right, so 10 yards we have in the numerator. So over here in the denominator, let's get rid of yards. In the denominator, we have 1 minute. So that means we need to set up another fraction that will be opposite that minute up top. So we have the minute up top so we can do our cancellations. And then we have the yards opposite each other so we can cancel the yards. All right, well, what do we know about our conversion? Well, we want to know about feet again. So we'll have feet in the numerator. And then what do we want to know in the denominator? We want to know about seconds in the denominator. So we can write that over here. All right, so what do we know about the comparison between feet and yards? Well, we've talked about that. We have 3 feet in 1 yard. And what do we know about the comparisons of minutes and seconds? Well, we know that 1 minute is equal to 60 seconds. Let's do our cancellations. I have the yard in the top, canceling with the yard in the bottom. I have the minute in the bottom, canceling with the minute in the top. And it looks like if we did our multiplication straight across, we'll come up with our final answer. So 10 multiplied by 3 is 30, multiplied by 1 is 30, over 1 times 1 times 60. And what are we looking for? Desired is the feet over the seconds, feet per second. And if we were to reduce that, 30 over 60 would reduce to 1 over 2. Final answer. All right, another one of these monsters here. We have 4 different units, so let's just go step by step. We start with 360 miles per 1 hour. So 360 miles over the hour. All right, who do we want to get rid of first? Why don't we just get rid of the miles? So we'll put miles in the denominator in our first one. And then our second one, we can get rid of the time. So we'll have to put hours opposite in the top. Okay, desired unit of measurement, we're looking for feet. And then for the time, we're looking for seconds. Let's do our cancellations here. Let's set up our comparisons first. Sorry about that. So what do we know about feet and miles? Well, we know that we have 5,280 feet in 1 mile. And we know that we have 60 seconds. Oh, I'm sorry, not 60 seconds. We're talking about an hour. So we have 1 hour, and previously we knew that we had 3,600 seconds in 1 hour. Okay, be careful with that one. Now let's do some canceling. Miles in the top, miles in the bottom, hours in the bottom, hours in the top, and we have our desired units left. We're looking for feet in seconds. All right, so this is going to be some heavy duty multiplication here, it looks like. All right, let's go with 360 multiplied by 5,280 multiplied by 1, which we know is still the same answer, all over 1 times 1 times 3,600. All right, can we do any canceling in the top and the bottom to make our math a little easier? Well, we know that 360 can cancel with what left over. We have a 0 left over, and that 0 will translate into a 10. All right, so if I were to rewrite this, I have 5,280 divided by that leftover 10, and you are going to end up with 528 upon your division. You can cancel out your zeros. 528 divided by 1 is 528. We are looking for the desired units of feet per second. All right, final answer. All right, moving away from the conversions now, number 43, we are going to do some rounding. All right, so if I'm rounding to the nearest thousandth, I'm looking at my positions. This is the 10th, the 100th, and the 1000th. So looking at this second 5, over to the right of it, that number is less than 5. So we are actually going to keep the 5 the same in that 1000th position. So we have 3, 455 thousandths. Final answer. Round 89 and 971 thousandths to the nearest tenth. So now we're looking at the 10th position. I need a number in the 10th position, so I'll look to the right of it. The 7 is more than 5, so I need to round that up 1. Well, up 1 would turn it into a 0, so I look to the left of that, and I make that one go up a unit. So we will have 89 rounds to 90. And I need a number in the 10th position. Please put that number in that 10th position because that's what they want. Final answer. Um, you know what? Let me go back a little bit and give you a symbol. Sorry. Let's go with the approximately symbol because it's not exact. When we're rounding, we are approximating. Okay. And then we have approximately 90. Sorry. Round the square root of 224 to the nearest whole number. Be careful what they want you to round to. So I'm looking for a whole number. 224 is not a perfect square, but I can find some people around it, some numbers around it that are perfect. So I'll center that right up. Find the one above and below. And I know that 225 is just after 224, and it is perfect, which is an answer of exactly the whole number of 15. And then I would need to know the one below it, which would have to be the answer of 14. And the perfect square, 14 would get you 196. And now, decision time. The distance on a number line between 224 and 196 is what, about 28 units? And the distance between these two is only 1 unit. So obviously 224 is closer to 225. So this would be approximately what? Who's it closer to? It's closer to 15. Final answer, approximately 15. Scientific notation. We have discussed scientific notation. We have a very small decimal number here, very tiny. The number to the left of it, of the decimal, needs to be between 1 and 9. So we're going to have to relocate this decimal over to the right there. And how many times? Well, if I move it one time, it's still 0. Another time, it's still 0 to the left. If I do it one more time, the number to the left of the decimal is between 1 and 9. We call it 5. So we have 5 and 43 hundredths. Well, if we're talking about scientific notation, to make up for that move of the decimal, we're going to multiply by some power of 10. All right, so what did we do? We took this small decimal number and made it larger. So we're going to be talking about a very small exponent then. And if you're talking about a small exponent, you're in the negatives. And how many times did we move it? 1, 2, 3 positions. So we're at -3. Final answer. All right, now we are looking at scientific notation, and we want to turn it, I don't know why it says write this in. Oh, I know why. Okay, so it's not really in clear scientific notation because this is not following that 1 through 9 rule to the left of the decimal. So the decimal is actually at the end if you don't see it, and it looks like I need to relocate it to the left. Well, if I only moved it one time, the number to the left is 39. That's too big. So I need to go one more time to the left. We're at 3.9 times 10 to the, all right, so we made an adjustment. We took 390 and turned it into a smaller number. We moved it 2 times, so I need to take this given exponent and kind of balance that out. So if I made this original number smaller, I'm going to have to make this power of 10 larger. And if I moved it 2 times, 2 times larger would be to the -4th. Now remember, when you're on the negative side of 0, we actually got closer to 0 by adding 2. So -6 plus 2 is -4. That's a common error sometimes we make. All right, I believe this is the last one for this video. Scientific notation. Now we want to turn it into decimal notation. So it looks good. You know, we have to the left between 1 and 9 and a power of 10, but they want to go back into a regular decimal. All right, so if I have 5 and 4 tenths and I'm multiplying by 1,000, think about that. 10 to the third power is 1,000. We're going to try to make this larger, so we're going to be moving this decimal 3 times to the right. 1, 2, 3, and we have 5, 4. Add in your zeros, and final answer, 5,400. Okay, that is the end of this video. I went through a full side of a page here for you, and I'll try to keep going as much as I can here. See you in class.